Next, we're going to talk about counting. So I'm going to take it back to like third grade right now. And if you recall, in third grade, you talked about the hundreds column, the tens column, and the ones column. So if you had a number like 123, you'd break it down into its composite values of 100, 20, and 3. Well, this can also be written as 1 times 100 plus 2 times 10 plus 3 times 1. But using our new power of exponents, we're going to write 100 as an exponent as power of 10, 10 as an exponent, power of 10, and 1 as an exponent, power of 10. So 123 is really equal to 1 times 10 to the power of 2 plus 2 times 10 to the power of 1 plus 3 times 10 to the power of 0. Let's do another one. 633 is equal to 600 plus 30 plus 3, which is really equal to 6 times 100 plus 3 times 10 plus 3 times 1. Writing this in exponents, 10 to the power of 2 is 100, 10 to the power of 1 is 10, and 10 to the power of 0 is 1. So 6 times 10 to the power of 2 plus 3 times 10 to the power of 1 plus 3 times 10 to the power of 0 is equal to 633. This is decimal, or because our exponent base is 10, it's a base 10 number system. But computers aren't very good at base 10, so we need to learn some binary. And the quintessential binary digit is called a bit, which is just short for binary digit. Bit, binary, digit. And in binary, there's only two numbers, 1 and 0. And binary is a base 2 system, but we've been using decimal, which is base 10, which has 10 numbers, and you're familiar with those, 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 different numbers, but they start at 0, 0 through 9. And in binary, which is base 2, there's two numbers, 0 and 1. So again, in the decimal system, we have such things as the 100s column, or the hundreds column, the tens column, and the ones column. And we could express these in exponent form, 10 to the power of 2, 10 to the power of 1, 10 to the power of 0. And in binary, we don't have the tens, hundreds, and ones. We have base 2 weighted columns, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. 2 to the power of 2 is 8, or 4. 2 to the power of 2 is 1, and 2 to the power of 0 is 1. And if we have a larger number, we'd have 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. And these columns are weighted 1, 2, 4, 8, 16, 32, 64, and 128. So here's an example of converting a binary number to a decimal number. So we're going to decompose this number, this binary number, just like we decomposed our decimal number. So our four columns, 0, 1, 1, 0, becomes 0 times 2 to the power of 3, plus 1 times 2 to the power of 2, plus 1 times 2 to the power of 1, plus 0 times 2 to the power of 0. 2 to the 3 is just 8, 2 to the 4 is 4, 2 to the 1 is 2, and 2 to the 0 is 1. If we multiply 0 times 8, that's 0, and 1 times 4 is 4, 1 times 2 is 2, and 0 times 1 is 0. Oops, I said 0. And this is equal to 6. So the binary number 0110 is equal to 0 plus 4 plus 2 plus 0, or 6. So here's another example. 1001 is in decimal is 1 times 2 to the power of 3. Oops, I said 3. 1 times 2 to the power of 2. Or 0 times... Hey, this guy doesn't know what he's doing. Oops, we better just start over on this one. 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, plus 1 times... You can do it. 2 to the power of 0. There you go. Okay, 1001 is equal to 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. And 2 to the power of 3 is 8. 2 to the power of 2 is 4. 2 to the power of 1 is 2. And 2 to the power of 0 is 1. 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. And 1 times 8 is 8. 0 times 4. Hey, we can't see the paper. That's better. Plus 0 times 2 is 0. Plus 1 times 1 is 1. So 1001 in binary is equal to 8 plus 0 plus 0 plus 1, which is equal to 9 base 10. We put the little radix to the bottom right of the number to indicate if it's base 2 or base 10. Okay, now I'm going to define a byte. A byte is 8 bits. And we'll give an example here of a byte. So 1001, 0001, that's 8 bits. And the far left bit is called the most significant bit. And the far right bit is called the least significant bit, or the MSB and the LSB. Again, this is a binary number, so it is weighted power of 2 columns. And the weights of the columns are 1, 2, 4, 8, 16, 32, 64, and 128. And if we just write the binary number below these column weights, we can multiply the column weight times the binary number, or the binary digit, the bit. So 1 times 128 is 1. And 0 times anything is 0. So 16 times 1 is 16. And 1 times 1 is 1. 16 plus 128 is 144, plus 1 is 145. So 1001, 0001 in binary is equal to 145 base 10.